All right, in section 5.6, the last section of chapter 5, we're talking about arithmetic sequences, or just arithmetic sequence. This should be pretty straightforward. It's nothing too terribly bad, but it actually will set the foundation for some other things that we're going to be doing in the future. So first off, a sequence is an ordered list of numbers. So here's an example. This is an ordered list of numbers. It's pretty straightforward. But here is another ordered list of numbers. And there is a difference between these things. One, they're written in order from lowest to highest, but there is something special about the difference between this and this, which we'll talk about in just a moment. All right, so the next piece of it is what we call the term. It's basically each number within a sequence. So this is the first term, second term, third term, fourth term, fifth term, and the same thing with this one. This is the first, second, third, fourth, fifth. So that's really all we're doing, is just basically labeling the terms. So nothing too complicated on that. All right, so if I wanted to know what the fourth term in the sequence was, I could look at this. 1, 2, 3, 4. So my fourth term in this sequence would be 60. Now, this is where we get to, that's not right, needs to be an M there, arithmetic sequence. The difference between consecutive terms is the sequences are the same. So I'm going to give you two examples here, 2, 4, 6, and 8. And then we have 3, 6, 12, 15, all right? So this one, if you notice that there's a difference of plus 2, plus 2, plus 2. This is a arithmetic sequence because the consecutive terms have the same difference. There's a difference of a positive 2 between each one. But I look at this one, I have a plus 3, a plus 6, and a plus 3. Notice that this is just a regular sequence. The numbers are in order, but because of this right here, the difference is not the same. Which brings me to the last definition, which is kind of a repeat of what we just said. Common difference. It's the difference found during an arithmetic sequence. So the common difference between this first one we talked about has a common difference of a positive 2. So, long story short, basically arithmetic sequences are finding patterns. You've done that before, probably when you were in upper L. So this is not that big of a deal. It's just got a new name. All right, so let's just go ahead and hit some things here. It says, write the next 3 terms in the arithmetic sequence. It tells me that the first term is 3, so I'm going to write that 3 down. And I have a common difference of 12, which would be a positive 12. So my next number would be 3 plus 12 gives me 15. The next number after that would be 27, followed by the number 39. That's it. I have the next 3 terms. That was my first, here's my second, here's my third, here's my fourth. Same concept with this one. My first term is 5, and I have a common difference of 1.3. So my second term is going to be 6.3. My third term is going to be 7.6. My fourth term is going to be 8.9. Not too terribly difficult. So now we're looking at the next piece. We have a arithmetic sequence in this, and it says find the common difference. Well, all we have to do is look at what it's counting by. Notice it's going 4, 8, 12, 16. Well, that means that I'm going up 4 each time. So my common difference for number 3 is 4. It has a common difference. Now, if we look at this one, it gets a little bit more complicated because we're working with some decimals, but hey, we can kind of figure it out. So let's kind of work ourselves backwards. We have 8.4 minus 7.7. That's a difference of 0.7. So I'm just going to write that down. Now let's do the next one. 7.7 minus the second term. Hey, that's also 0.7. And now 7 minus 6.3 is also 0.7. So the common difference of each and every one of these from one term to the next is 0.7, or 0.7 to be exact, which is 7/10. And then this next one. This one's actually pretty easy. You can look at it. 200, 500, 800, 1100. it's going up by 300 each time. 200 plus 300 is 5. 500 plus 300 is 800. 800 plus 300 is 1100, and so forth, so on. All right, so the next one, write the next three terms in the arithmetic sequence. So we have 1, 10, 19, 28, and we need to go through the next three terms. So basically, we have to ask ourselves, what is the common difference? Well, this one's straightforward. Notice that it's going up 9 each time. So I can go 28 plus 9. Then I can go plus 9 again in my calculator, and then plus 9 again. And I find out that my next sequences are going to be, according to my calculator, 37, 46, and 55. Let's try 7 and 8 on your own, just to give you a little. So what you should have gotten for number 7 was 10, 10 and a third, 10 and 2/3. So how did I get that? Well, let's just look at what's going on. I know that 8 and 2/3 went to 9, and if I know my rules of fractions, basically I just added a third. 8 and 2/3 plus a third equals 9. Add another third equals 9 and 1/3. Add another third, 9 and 2/3. Then we get 10, 10 and 1/3, 10 and 2/3. And we can continue going. So if you look at the next one, 10 to 25, that's going to be a plus 15 for my common difference. And I'm going to have the same thing. 25 plus 15 is 40, plus 15 is 55. Continue that pattern, I get 70, 85, and 100. Nothing complicated. Now, the next piece, it says, determine whether the sequence is arithmetic. If so, or find the common difference. All right, so basically we just look at it. This has a plus 3, this has a 6, and this has a 12. Right from the get-go, there is no common difference, so therefore the answer is no. This is not arithmetic sequence. When we look at this one, I have a common, it's going up of 5, 6, so we need to find out if it does the same thing. So we need to put 1 and 2/3. So how do we do that in this calculator? And this is where I want to show you a little bit. The TI-30s are easier with using a calculator and putting fractions in, but we still need to be able to do this. So we can say 1 plus 2 divided by 3. What I did is that's my whole number, and here's my fraction. And this gives me 1 and 2/3, and it puts it as a decimal. This is one of the drawbacks of a graphing calculator, is that you've got to remember that a fraction can be turned into a decimal. And now that I have 1 and 2/3 in my calculator as this decimal, I can subtract 5, 6. Oops, and I'm going to put them as a parentheses. All right, so what do I get? I get this weird number, but is that the same thing as the other one? Well, what we have to do now is change this into a fraction we understand. So we can go to what's called Math button, and then it says fraction. So I'm going to hit enter, and it's going to take that decimal and turn it to a fraction for me, and it gives me 5, 6. So right now I have a difference of 5, 6 between the first and second term, and the same thing with the second and third. Let's see if that works again. So what I'm going to do is I'm going to go 1 plus 2/3 and have that in my calculator. And now this time I'm going to add 5, 6. And if this is indeed my common difference, it should equal up to 2.5. So I want to add 5, 6 by putting it in as a fraction, as a parentheses. I hit enter, and I get 2.5. Well, 2.5 is indeed 2.5. So my common difference for this is 5, 6. All right. I'm actually going to leave 11 for you as a challenge problem, because this is a pretty easy little concept that we're doing just at the end of chapter 5. And as always, you know how to find me to ask questions, and I'll see you in the next video. Bye-bye.